Hello, my name is Andy. Today we are going to demonstrate how to assemble and operate a PhosphonicS Falcon scavenging unit. This is the Falcon unit, and let's briefly talk about what it's used for. It is designed for scale-up trials for precious metal recovery. We offer a range of different engineering solutions for scale-up trials, but if the Falcon unit is suitable, this tends to be our preferred option, as it is designed to be simple to install and operate. It is a plug-and-play unit. On receipt, the Falcon needs unpacking and requires assembly. You will receive one Falcon base unit, one pre-packed column, and one column adapter to connect the column to the Falcon base unit. A pump is usually required for effective operation. This is not usually supplied by PhosphonicS, but we can provide guidance on suitable pumps. This is an example of a pump. In this case, it's a peristaltic pump. Let's look at the Falcon base unit. It is made of stainless steel and currently can come with either PVC or PVDF fittings and connections. Its upper operating temperature is 49 degrees C, limited by the column. Whatever the fitting and connections, the unit is assembled and operated in the same way. If we turn the base unit around, you can see three connections on the back. The top is the inlet or influent, the middle is the outlet or effluent, and the bottom is the drain. The connections can be in different types, from compression bulkhead, a union fitting, barbed hose connectors for tubing or hoses to be secured to the unit, and for the PVC option, a 16mm solvent weld union. We usually recommend the hose connection for short-term trials. These hose connectors are usually 9 to 12mm in diameter. Suitable flexible tubing can then be secured to the hose connector with a Jubilee clip. Turning to the front of the Falcon unit, we have the diaphragm valve and the two L-port valves and the flow meter. The diaphragm valve controls the flow of liquid, which is measured with the variable area flow meter. The standard flow meter is made from polyamide with PVC connections with a standard flow rate 0 to 25 litres per hour, but it can be changed for different flow rates or different chemical compatibility. In this device, this is a 0 to 50 litre per hour, and this is in glass. The flow meter allows a visual check that liquid is flowing through the equipment and that it is flowing at the desired rate. The L-port valves allow either flow to enter into the column with both pointing to flow, or for the column to be drained with one on drain and one on vent. Moving on to the top of the Falcon base, we can see two nozzles or spigots. These spigots each have two O-rings which can be pre-greased with petroleum jelly to ensure a good seal between the column and the Falcon unit. The curved metal shield protects the column from knocks and bangs when in operation. The Falcon unit uses columns which are typically fiberglass reinforced HDPE lined, otherwise known as GRP columns. We have some examples of suitable columns here, and you can see the standard sizes. This is a 7 litre, and this larger example is a 20 litre. Other sizes are available. Alternative column linings are also available if there are chemical compatibility issues with the standard HDPE lining. The internal pipework inside the column are usually PVC, but polypropylene is also available if there are chemical compatibility issues with the standard PVC. PhosphonicS supplies columns that are packed with silica scavenger and ready to connect to the Falcon unit. As you can see, the silica scavenger is a free-flowing amorphous solid. From an operational point of view, we think it's helpful to understand what's inside the packed column. There is a filter with 200 micron slits, as this system is designed for use with the PhosphonicS recovery grade products such as Phos4. The filter comes pre-assembled with a length of tubing forming the axial return pipe. This unit fits into the column adapter. This ensures the filter is in the top of the column when in use. This is our proprietary column adapter that is designed to connect the column onto the two spigots of the Falcon unit. The front spigot is the inlet to the column. The top of the column adapter has a threaded connection for the column, and this groove takes an O-ring to seal the column to the adapter. The central socket Seals on the axial return pipe and the space around the central orifice in the column adapter has been pre-packed with glass wool to act as a filter to keep the silica in the column. On the other side, the adapter has a 20mm lip with 2 holes. The central hole is the outlet or effluent socket, and the other hole is the inlet or feed socket, which is located towards the front of the adapter. The outside of the adapter has a vertical groove or line to aid in identification of the front of the adapter. The groove should line up exactly with the middle of the 2 holes. The liquids will rise through the column to the filter and return pipe. A packed column will have the axial return pipe already in place, and the column adapter is placed on top of the column and screwed in tight until it seals onto the column. You can see it's sufficient to screw it hand tight, and this is then ready to attach to the Falcon unit. Before fixing the column onto the spigots, we recommend checking the spigot O-rings for any damage. If necessary, the O-rings can be pinched with pliers or tweezers and taken off and replaced. The use of petroleum jelly or grease can aid mounting and dismounting the column. To attach the column to the Falcon, you will need to invert the column and line up the arrow on the surface of the Falcon with the groove on the front of the adapter. It may take millimetre moves left to right and front to back, but it should locate the column on the 2 spigots. It may take some downward force to fully locate down on the top of the Falcon. The adapter should fit flush with the stainless steel surface of the Falcon. The central hole goes on the back spigot. There should be no movement of a packed column when it is securely located on the spigots. The Falcon unit is now assembled. We are now going to talk about the operation of the Falcon. The flow of liquid into the Falcon from the stream feed can be provided by different methods. A gravity feed may be possible if the desired flow rate can be achieved, but we usually recommend a peristaltic pump such as a Watson-Marlow 500 series. Any other pump which is compatible with the stream and can pump the stream in a controlled fashion to give similar performance and the desired flow rate would also be suitable. If the stream does or could contain solid particles, then an inline filter is recommended. Without a filter, back pressure in the system could build or the column could become blocked. A cartridge such as a 28 series housing from Amazon Filters is usually suitable with a SuperGuard 10 micron cartridge. Other equivalent filters are also suitable. If an inline filter is required, this is positioned between the feed and the Falcon unit. PhosphonicS usually recommends the use of columns in upflow, and this is how the Falcon is designed to operate. The liquid rises through the column from the bottom to the top, where there is less chance of the liquid bypassing the scavenger. It also means the columns are less sensitive to how well the scavenger is packed, because the liquid flow, working against gravity, ensures the column self-packs. The feed, effluent and drain lines must be secured, for example, with Jubilee clips to ensure a tight, leak-free connection. The liquid flow can either be controlled by the pump or with the diaphragm valve. The control valves are placed in the flow position to operate the column and recover your metal. The liquid will fill into the column and the air will be displaced by the liquid. The liquid flow is determined based on the results of the stream testing carried out previously. For more information, you can see our phase video, which explains our testing protocols. The liquid effluent from the column is sampled and analysed for metal content during the trial. If the system is working correctly, there should be none of the target metal in the effluent leaving the column until the column gets close to saturation. We also recommend sampling and analysis of the influent periodically during the trial to confirm the liquid stream remains constant. Changing the temperature of the stream in the column or reducing the flow rate can increase the metal recovery. When the column is saturated, the flow is stopped and the column isolated from the feed tank. The diaphragm valve is closed. The L-port valves are moved to the drain and vent positions, and the stream drains from the column into the drain line. When the flow from the drain line is finished, the column should be empty of liquid. The column can now be lifted off of the Falcon, but care should be taken as the column will now be heavier as it contains liquid in the silica pores. It it may be in the region of 20 to 30 kilograms for a 20-litre column. The column is placed on a flat surface on its base with the column adapter on top. The column adapter can be unscrewed to give access to the silica. The silica here can then be sampled to analyse for metal loading. If the effluent and influent levels are equal, then the column should be equally saturated through the whole length of the column. A sample coring device can be used if necessary to take samples at different heights in the column. When the metal content of a stream is very low, it can be more useful to take the column off periodically to analyse the solid to understand how well the metal recovery is going. We supply a manual with detailed instructions on its safe operation with every Falcon unit, and we are happy to help you with any queries in either the setup or operation. It is a simple system to use, and we have described a Falcon unit operating as a single unit with one column. However, multiple Falcon units can be used in either parallel or series. Thank you for listening.